Hey there, listeners. Got a really fascinating deep dive lined up for you today.
Oh, cool.
All about the life and achievements of Igor Tamm, a name you might not recognize right off the bat.
Right.
But trust me, stick with us. By the end of this, you'll totally get why this guy deserves a spot on your radar. You know what I mean?
Looking forward to it.
So, you sent over some super intriguing biographical material on Tamm, and it's clear this Soviet physicist, his story, well, it's anything but ordinary.
Yeah.
I mean, we're talking Nobel Prize-winning discoveries,
Yeah.
Cold War secrets, and even, get this, something called a tokamak.
The Tokamak, huh?
Don't worry, we'll explain all that.
Sounds mysterious.
All in a day's work for Igor Tamm, apparently.
Uh-huh. Well, he certainly got around.
So, to help us unpack all of this,
Mm-hmm.
I've got our expert here with us today to kind of shed some light on the significance of Tamm's work and, how it all fits into the bigger picture of physics and history.
Happy to help.
Awesome. So let's just dive right in. Tamm was born in Vladivostok, Russia, way back in 1895.
Okay.
And the sources you sent, they kind of hint at a potentially mixed German and Jewish heritage,
Interesting.
which, gets you thinking about his family background and the kind of influences that were swirling around him, during those early years.
Yeah, for sure. I mean, Vladivostok back then,
Right.
it was a real melting pot of cultures.
Totally.
And the late 19th century in Russia, that was a time of huge social and political change.
Makes you wonder if those early experiences kind of planted the seeds for his later involvement in the Russian Revolution.
Oh, absolutely.
Right. But before we get ahead of ourselves,
Sure.
I'm curious about his time studying at the University of Edinburgh
Okay.
with his friend Boris Hessen.
Right.
Now, Hessen himself, he was a pretty influential figure in the history of science, wasn't he?
Oh, absolutely he was.
Yeah.
He became well known for his work on, the sociology of science, exploring how social and political factors influence how science develops. Yeah. Having these two minds studying together in Edinburgh, I mean, that suggests a really, really vibrant intellectual atmosphere.
For sure.
It's especially striking, though, that Tamm and Hessen chose Edinburgh in the first place.
Right?
It wasn't actually that common back then for Russian students to go abroad for their education. It suggests a real thirst for knowledge, a willingness to engage with, different perspectives.
Yeah, totally.
Which, we see throughout his life.
Totally. So
Yeah.
we're kind of seeing a pattern here, right? This intellectual curiosity
Yeah.
and a real drive to go beyond the familiar. It's just fascinating to see how these early choices might have shaped his path,
Definitely.
But then, of course, World War I happens.
Right, yeah.
The world is kind of plunged into this chaos, and we see Tamm volunteering as a field medic.
Wow.
I mean, that's a pretty remarkable act of compassion in the midst of all that, isn't it?
It really is. It shows, a deep humanitarian impulse,
Yeah.
a willingness to put himself in danger to help others,
Yeah.
And I think it's crucial to consider the psychological impact of those wartime experiences too, right? Witnessing, firsthand the fragility of life, the just devastating consequences of conflict.
Right.
How could that not leave a lasting impression on someone?
Yeah. I mean, it's hard to even imagine. I think it adds another layer of depth to his character.
Definitely.
And then, of course, the world is, turned upside down again by the Russian Revolution.
Of course.
And to Tamm, he doesn't just witness these, seismic events.
Right.
He actually gets actively involved.
He does.
Do we know anything about the specific roles he played during that time?
Well, the sources indicate that he served on various committees after the March Revolution, contributing to the effort of building a new society, from the ground up.
Wow.
It's important to remember that the Russian Revolution wasn't just about political upheaval. It was a period of intense intellectual and ideological, ferment. Scientists and intellectuals were actively debating, the role of science in society,
Right.
how it could be used to build a better future.
So we've got Tamm right in the thick of it, right? Not just observing these changes, but actively participating in shaping the direction of his country. And all while, pursuing his scientific career.
It's amazing.
I know. And amidst all of this, he finds time to marry Natalia Shuskaya.
Oh, wow.
And they go on to have 2 children, a chemist and a physicist.
Wow, science really runs in the family.
Clearly. It's certainly suggestive of a household where, intellectual curiosity and scientific debate were just part of daily life.
You can almost picture those family dinners filled with lively conversations about the latest scientific breakthroughs.
Oh,
And
totally.
the possibilities of the future, right?
It paints such a vivid picture.
It does.
So we're seeing a man who is deeply engaged with, both the scientific and political landscape of his time, someone who's experienced both the horrors of war and the hope of revolution.
Powerful combination.
Yeah, it's the kind of foundation that just makes you so curious about what he'll accomplish next.
Right.
Right. And that's where his scientific career really takes off.
Yeah.
I was genuinely surprised by the sheer range and depth of his contributions.
He really was a multifaceted scientist,
Yeah.
constantly pushing the boundaries of different fields.
It's fascinating to see how his early work, even before the revolution really settles,
Right.
tackles some really fundamental problems in physics. For example, he dives into the electrodynamics of anisotropic media,
Okay.
which essentially, explores how light behaves in materials with different properties in different directions.
Right.
And then he jumps into the special theory of relativity,
Wow.
grappling with Einstein's revolutionary ideas about space, time, and gravity.
All this while still in his 20s.
I know, it's mind-boggling, right?
Right.
He's not just, dabbling in these complex areas.
Right.
He's already publishing significant work and making a name for himself.
Really impressive.
And then he gets the opportunity to spend time with Paul Ehrenfest at the University of Leiden
Oh, wow.
and forms a lifelong friendship with Paul Dirac.
Okay.
Now, these are two giants of theoretical physics.
They are.
I'm dying to know, what kind of conversations might these brilliant minds have had,
Oh, right.
and how did those interactions potentially shape Tamm's thinking?
That's where it gets really interesting. I mean, Ehrenfest, he was known for his incredible intuition.
Right.
And his ability to get to the heart of a physical problem. And Dirac was a pioneer of quantum mechanics.
Of course.
Famous for his, elegant mathematical formulations and his prediction of antimatter.
Right.
So imagine Tamm, a young, ambitious physicist, soaking up their wisdom, debating the latest breakthroughs, and challenging his own assumptions.
It must have been like an intellectual boot camp for him.
Haha, yeah.
Right, sharpening his mind, pushing him to think even more deeply about the nature of the universe.
Definitely.
And after all this, he returns to the Soviet Union and takes on the prestigious role of head of the theoretical department at the Lebedev Physical Institute in Moscow.
Wow.
It sounds like he's really cementing his place as a leading figure in the Soviet scientific community.
Absolutely. The Lebedev Institute, that was a powerhouse of physics research.
Yeah.
And leading its theoretical department, that signifies a level of recognition and respect. I mean, that's hard to overstate.
For sure.
And this is where he really begins to assemble his own school of thought,
Oh, interesting.
mentoring the next generation of Soviet physicists and shaping the direction of research for years to come.
But he doesn't just settle into a comfortable academic life, does he?
He doesn't.
I mean, look at what he accomplishes next. He proposes this concept of surface states.
Okay.
And get this seemingly abstract idea. It turns out to be absolutely crucial for the development of something called MOSFET technology,
Right.
which is the basis for, wait for it, transistors.
Transistors.
I mean, we're talking about a fundamental component of computers, smartphones, pretty much all the electronics that define our modern lives.
It's amazing, isn't it, how these fundamental discoveries
Right.
have such a ripple effect.
It's incredible.
You're absolutely right.
It's a perfect example of how Tamm's work spanned both the theoretical and the practical.
Exactly.
With profound implications that, he might not have even fully anticipated at the time.
Right. Who knows what he was thinking?
Right.
But he set the stage for so much.
He's grappling with the behavior of electrons at the surface of materials. A very fundamental question, right?
Yeah.
And yet it lays the groundwork for a technological revolution that would transform society decades later.
It's remarkable.
So we've got a picture of Tamm as someone who's not afraid to delve into the most abstract theoretical problems,
Right.
but who also has an eye for how those ideas might connect to the real world and potentially, shape the future.
Absolutely.
It's a really remarkable combination.
It is.
And honestly, I'm even more intrigued now to see where he goes from here.
Me too. And his next move is even more surprising. He teams up with Seaman Altshuler, and they propose this really bold idea that the neutron long thought to be neutral, no charge, actually has a non-zero magnetic moment.
Whoa, that must raise some eyebrows in the physics community.
Oh, yeah.
I mean, at that time, the neutron was considered an elementary particle.
Mm-hmm.
So how could something with no charge have a magnetic field?
Right.
It seems like they were really challenging the conventional wisdom about the fundamental building blocks of matter.
They were, and their suggestion, it was initially met with, a fair bit of skepticism,
Sure.
as you might imagine. But what's fascinating is that they were tapping into this growing sense that the neutron was more complex than initially thought.
Interesting.
Their idea, while not immediately accepted, contributed to a shift in perspective that ultimately led to a deeper understanding of the neutron's structure and the forces at play within the atomic nucleus. So it's a great example of how a seemingly radical idea can, over time, reshape our understanding of the universe.
Totally. So they kind of planted a seed of doubt, and that seed eventually grew into a whole new way of thinking about the neutron.
Exactly.
I love that.
Yeah.
It shows that even the most established ideas in science can be challenged and refined, as new evidence emerges.
Right.
And speaking of challenging established ideas, Tamm goes on to suggest that the interactions between protons and neutrons in the nucleus can be described as an exchange force.
Okay.
A force transmitted by some, at the time, unknown massive particle.
This is where Tamm's work connects to one of the most significant breakthroughs in nuclear physics.
Oh, wow.
His idea, while lacking a specific particle to carry this force, provided the conceptual framework that inspired Hideki Yukawa's later theory of meson forces.
Interesting.
So Yukawa, building upon Tamm's foundation, proposed the existence of a particle called the pion, which acts as the carrier of the strong force, binding protons and neutrons together in the nucleus. It's a testament to the collaborative nature of science, where one scientist's ideas can spark a chain reaction of discoveries.
So Tamm's insight essentially paved the way for a whole new understanding of how the nucleus holds together.
Well, it did.
It's amazing to see how these threads of scientific thought, intertwine, each discovery building upon the work that came before. And while he's laying the groundwork for these future breakthroughs, he's also developing powerful tools for solving some of the most complex problems in physics.
He was a busy guy.
I'm thinking specifically about the Tamm-Dankoff approximation.
Okay.
Which sounds pretty intimidating.
Yeah.
Can you give us a simplified explanation of what it is and why it's so important?
Sure. So imagine you're trying to describe the behavior of a system with many interacting particles, like, for example, the electrons in a solid or the nucleons in an atomic nucleus. It can get incredibly complex very quickly. The Tamm-Dankoff approximation offers a way to simplify these problems by focusing on the most important interactions and neglecting the less significant ones.
Okay.
It's like creating a manageable model of a complex system, allowing physicists to make calculations and predictions that would be impossible otherwise.
Right. So it's kind of like creating a map that highlights the major highways but leaves out the smaller side roads.
Exactly. It gives you a clearer picture of the overall landscape without getting bogged down in all the details.
Makes sense. And it's still used today, isn't it?
Oh, yeah, it is.
In various areas of physics.
From condensed matter to particle physics.
And this is just one of many contributions he makes.
Yeah.
It seems like he was constantly pushing the boundaries, exploring new ideas, collaborating with other brilliant minds.
Definitely a theme in his life.
And then, of course, there's the Nobel Prize.
Ah, yes, the Nobel Prize.
Awarded in 1958, jointly with Pavel Cherenkov and Ilya Frank.
Right.
For their work on a phenomenon that, at first glance, might seem like a curiosity, Cherenkov radiation.
A curiosity, maybe, but with some incredible applications.
Right, that mysterious blue glow.
Exactly.
Can you break it down for us? What exactly is Cherenkov radiation, and how did Tamm get involved in its discovery?
Okay, so the story begins with Pavel Cherenkov, who in the 1930s was experimenting with radioactive materials. And he noticed that when these materials were immersed in water, they emitted this faint blue light. It was a puzzle because this light didn't seem to fit any known phenomenon at the time.
Interesting.
Intrigued, Tamm and Ilya Frank, his longtime collaborator, took on the challenge of explaining this strange glow.
So Cherenkov makes the observation, and Tamm and Frank step in to provide the explanation.
Precisely.
Okay, cool.
And what they discovered was that this blue light, now called Cherenkov radiation, occurs when a charged particle, like an electron, moves through a medium, like water, faster than the speed of light in that medium.
Wait, hold on a minute.
Yeah.
Nothing can travel faster than the speed of light.
You're right, if we're talking about the speed of light in a vacuum.
Okay.
But light actually slows down when it travels through a medium, like water or glass.
Oh, I see.
So it's not that the particle is breaking the ultimate speed limit. It's just outpacing light in that specific environment.
So it's not like breaking the laws of physics or anything?
No, not at all.
Gotcha.
And when that happens,
Yeah.
it creates a kind of shock wave of light,
Okay.
similar to the sonic boom created by an airplane exceeding the speed of sound.
Okay.
That shock wave is what we see as Cherenkov radiation.
That's a fantastic analogy.
It is, isn't it?
It makes this abstract concept much easier to grasp.
It does.
So we have this beautiful blue glow, but what makes it so important? Is it just a pretty light show, or is there something more to it?
Oh, it's far more than just a pretty light show.
Okay.
Cherenkov radiation has some incredibly practical applications.
Like what?
Well, for example, it's used in particle detectors to identify and study high-energy particles.
Okay.
Imagine a cosmic ray, a super-fast particle from outer space, slamming into Earth's atmosphere.
Right.
It can produce a shower of secondary particles that, in turn, generate Cherenkov radiation.
I see.
Scientists can detect this radiation and use it to reconstruct the path and properties of the original cosmic ray,
Interesting.
gaining insights into the most energetic processes in the universe.
So it's like a cosmic fingerprint, allowing scientists to trace these, like, elusive particles back to their origins.
Exactly.
That's incredible. Are there any other applications?
Oh, there are many.
Okay.
It's also used in medical imaging, particularly in a technique called positron emission tomography, or PT scanning.
PET scanning. Okay.
On PET scans, a small amount of radioactive material is injected into the body,
Right.
and the emitted positrons produce Cherenkov radiation as they interact with the surrounding tissue.
Interesting.
Detectors pick up this radiation and use it to create three-dimensional images of organs and tissues, allowing doctors to diagnose and monitor a wide range of conditions, from cancer to heart disease.
Wow. So this seemingly esoteric phenomenon has a real impact on our lives.
It does.
From helping us understand the universe to diagnosing illnesses.
Right.
It's a testament to the interconnectedness of science.
Yeah,
And how even the most unexpected discoveries can lead to practical benefits.
it really is.
But I think we need to acknowledge the other side of Tamm's legacy.
Oh, right.
The one that's much more controversial.
Mm-hmm.
I'm talking, of course, about his involvement in the development of the Soviet hydrogen bomb.
Right.
It's a chapter of his life that's hard to reconcile with the image of the brilliant scientist we've been discussing.
It's a complex issue, for sure.
Yeah.
Here we have this brilliant mind deeply engaged with fundamental questions about the universe.
Right.
And yet he's also contributing to the creation of a weapon with unimaginable destructive power.
Right.
It raises a lot of questions about the role of scientists in society, the ethical dilemmas they face, and the potential consequences of scientific knowledge.
Absolutely. The sources mention that he spent a significant amount of time in Surov, a secret city dedicated to nuclear weapons research,
Right.
heading the theoretical group developing the hydrogen bomb.
Wow.
What can you tell us about this period of his life? What kind of pressures and motivations might have been at play?
Well, the late 1940s and early 1950s were a period of intense Cold War tensions, right?
Yeah.
The Soviet Union, having successfully tested its first atomic bomb in 1949, was now in a race with the United States to develop even more powerful thermonuclear weapons.
Oh, wow.
Imagine the atmosphere of secrecy,
Yeah.
the pressure to succeed,
Right.
and the weight of knowing that your work could have global consequences.
Heady stuff.
It must have been an incredibly intense and
Wow.
morally challenging environment.
Undoubtedly. It's important to remember that the world had just witnessed the horrors of Hiroshima and Nagasaki,
Of course.
and the threat of nuclear war loomed large.
And-
For scientists like Tamm, who had seen the devastation of conventional warfare firsthand,
Right.
the development of nuclear weapons might have been seen as a necessary evil,
Right.
a deterrent to prevent even greater destruction.
A very difficult decision.
Of course, this perspective is highly debated, and the ethical implications of his involvement are something, we could discuss at length.
Absolutely.
But what's fascinating is that he doesn't stay in the world of weapons research forever.
Yeah, he doesn't.
I mean, after the successful test of the Soviet hydrogen bomb in 1953,
Right.
he retires from the project and returns to the Lebedev Institute.
Right.
It's almost as if he's stepping back from the brink,
Yeah.
seeking a return to a world of pure scientific exploration.
Right.
It seems like a pivotal moment in his life, and I'm curious about what he does next.
It's pretty amazing how after, delving into that destructive power of nuclear weapons,
Right.
he turns his attention to a totally different challenge.
Yeah. Harnessing that power of nuclear fusion for peaceful purposes.
Absolutely. And it's around this time that he starts collaborating with another prominent Soviet physicist,
Right.
Andrei Sakharov,
Right.
on a project that would become his lasting legacy, the Tokamak.
The tokamak, you mentioned it earlier.
Mhm.
I think it's worth exploring in more detail.
For sure.
So what exactly is a tokamak?
Right.
And how did Tamm and Sakharov envision it as a solution to, the world's energy needs?
Well, to understand the tokamak, we need to go back to the concept of nuclear fusion.
Okay.
In a hydrogen bomb, uncontrolled fusion reactions release a huge amount of energy in an explosion.
Right.
What Tamm and Sakharov were striving for was controlled thermonuclear fusion,
Okay.
a way to harness the power of the stars, but in a safe, sustainable way here on Earth.
So instead of unleashing this catastrophic burst of energy,
Yeah.
they wanted to create a steady and controllable source of power.
Exactly. The
Yeah.
tokamak is essentially a donut-shaped device.
I don't.
Yeah, it uses powerful magnetic fields to confine a superheated plasma,
Okay.
a state of matter where atoms are stripped of their electrons, creating a swirling sea of charged particles.
Well, that sounds pretty intense.
It is.
So within this plasma,
Mm-hmm.
fusion reactions can occur,
Yes.
releasing energy in the form of heat.
Exactly.
It sounds incredibly complex,
It is.
both in terms of the science and the engineering required to build such a device.
Oh, it's incredibly complex. The challenges of creating and maintaining a stable plasma
Right.
at temperatures hotter than the core of the sun are immense.
Yeah, I can imagine.
But the potential rewards are equally immense.
Oh.
A clean, nearly limitless source of energy that could, in theory, power entire cities.
Wow.
It's a vision that has captivated scientists and engineers for decades.
And how did Tamm and Sakharov's work contribute to this, ongoing quest for fusion energy?
Right.
Did they manage to achieve controlled fusion with their tokamak?
Well, while they didn't achieve sustained energy-producing fusion reactions, their work was absolutely foundational to the field.
Interesting.
They laid the theoretical groundwork
Mm-hmm.
and demonstrated the feasibility of magnetic confinement as a potential path towards controlled fusion.
Okay.
Their tokamak design became the basis for countless experiments and refinements over the years.
Wow.
And to this day, it remains one of the most promising approaches to achieving practical fusion energy.
So their work is still relevant today?
Oh, absolutely. In fact, there are major international collaborations.
Oh, wow.
Like ITER, the International Thermonuclear Experimental Reactor,
Okay.
currently under construction,
Wow.
that are directly building upon the principles first explored by Tamm and Sakharov.
So even though controlled fusion is still a goal on the horizon,
It is.
their work planted the seeds for a potential energy revolution
Right.
that could transform the world. It's a powerful legacy,
It is.
and one that seems fitting for a scientist who spent a significant part of his career grappling with the destructive power of the atom.
It's almost poetic, isn't it? From the destructive force of the hydrogen bomb to the potential of a clean and limitless energy source.
Right.
It reflects the duality of scientific progress,
Mhm.
the possibility for both immense harm and profound benefit.
Right.
It's a reminder that the choices we make about how we use our knowledge, how we direct our scientific endeavors,
Right.
have enormous implications for the future of humanity.
It makes you wonder what Tamm himself might have thought about this later chapter of his work,
Yeah.
his contributions to, the pursuit of fusion energy. Do we have any insights into his motivations or reflections on this shift in focus?
Unfortunately, the sources you provided don't offer much in terms of his personal reflections on this transition.
Okay.
However, we can speculate that, after witnessing the destructive potential of uncontrolled nuclear reactions,
Right.
he might have felt a sense of responsibility,
Mhm.
perhaps even a moral imperative, to explore the peaceful and beneficial applications of nuclear science.
It makes sense. After confronting the darkness of nuclear weapons, he might have sought a path towards a brighter future.
Absolutely.
A world where the power of the atom could be harnessed to illuminate our cities, not destroy them.
Powerful image.
It's a compelling narrative,
It is.
and one that resonates with the broader story of scientific progress in the 20th century.
For sure.
Tamm's life and work, it encapsulates both the triumphs and the challenges of scientific discovery, the ethical dilemmas,
Right.
and the profound impact that science has on society.
He really does.
It's a lot to take in, but I feel like we've gained a much deeper understanding of who Igor Tamm was
Yeah,
and why his story matters.
definitely.
He was more than just a brilliant physicist.
Right.
He was a witness to history, a participant in revolutions, both political and scientific,
Absolutely.
and a complex figure whose legacy continues to shape our world.
Absolutely.
So what does all this mean for you, our listener?
Yeah.
You've just completed a journey through the life and work of Igor Tamm,
What a journey.
a journey that took us from the bustling port of Vladivostok to the hallowed halls of the Nobel Prize ceremony, from the depths of Cold War secrecy to the bright promise of fusion energy.
Wow.
You've encountered a man who is both a product of his time and a shaper of the future.
Yeah.
A scientist whose legacy is intertwined with some of the most consequential events of the 20th century.
Powerful stuff.
Perhaps you're now inspired to explore some of these topics in more depth. Maybe you'll dive into the intricacies of Cherenkov radiation,
Right.
or delve into the current state of tokamak research and the ongoing quest for fusion energy.
Mm-hmm.
Or perhaps Tamm's story has sparked broader reflections
Yeah.
on the role of scientists in society,
Absolutely.
the ethical dilemmas they face,
Yeah.
and the power and responsibility that come with scientific knowledge.
For sure.
Whatever path your curiosity takes you on,
Mm-hmm.
just remember that behind every scientific discovery, every technological advancement,
Yeah.
there's a human story waiting to be uncovered.
Right.
A story that connects us to the past and illuminates the possibilities of the future.
I love that.
And until next time, keep exploring, keep questioning, and keep diving deep.